purpose of today's talk is a continuation of the discussion that we had yesterday, Wednesday. Sorry, the discussion that we had on Wednesday, um, talking about the falling apple, the falling moon, and the falling earth. So, where we pick up here, Newton had a hypothesis that he wanted to take it a little bit further to a scientific theory, and the only way to do that is that it needed to be tested over time. He reasoned that the moon's mass shouldn't have an effect on how it falls, just like things that fall here on Earth are not affected by mass when they are freely falling, meaning only gravity acting on them. So, how far the moon or the apple is from the Earth's surface should be the only real issue dealing with the amount of gravity. All right, so he knew that the moon had already been kind of described or said to be 60 times further than the center of Earth to where the apple would be on Earth's surface. So the moon's distance is 60 times farther than really the diameter, or sorry, the radius of Earth. And I just went ahead and found a couple of other things because, when we talk about planetary bodies, it's worth noting what kind of distances we're talking about. So the distance from Earth to the moon is 238,900. So 238,900 miles. 238,900 miles. And I wanted to know, well, if we went around the Earth one time, how many miles that would be? It'd be about 24,901 miles. So if you went around the Earth 9.5 times, that's the distance from Earth to the moon, right? So then I was like, all right, well, I can't really put that into perspective because the Earth is so big. So let's try to get it into maybe something that we could use. The distance from Atlanta to Hawaii, just if you fly straight as a bird would fly, is 4,502 miles. 4,502 miles. If you did that 5.5 times, that would essentially be like you going around Earth one time. And if you did it 53 times, go from Atlanta to Hawaii 53 times, that's essentially you going to the moon. So just trying to put that into perspective. Okay, so now that we've got that down, he knew that 60 times farther the moon was from where the apple would be falling towards Earth. And he said the apple will fall 5 meters in its first second. We'll look at where that comes from. It comes from an equation that we've already talked about in the past. But he said, as it gets further away, the gravitational attraction, that force that we feel, is somewhat diluted. And he said the influence of gravity should be diluted by 1/60 of 1/60. So 1/60th of 1/60th is what the dilution should be. So if that is true, in 1 second, the moon should fall 1/60th squared of 5 meters, which would be 1.4 millimeters. So we're talking about a very, very small amount. So here's just a couple of diagrams kind of depicting that. The apple falls towards Earth in Earth atmosphere. We've already established that. And that's really based on this equation. And let me see if I can't put that up. And that's D equals 1/2 GT squared. And if we substitute 1 second for time, and we know that gravity is 10, 9.8, but we say 10. So 1 squared is 1. Half of 10 is 5. 5 times 1 would be 5 meters. So in the first second, it falls 5 meters. That's where that 5 meters comes from, okay? And essentially the second picture over here is what an apple would fall if it was the distance from Earth to the moon. Notice that we're talking about center points here. So center points are important. We're not talking about the surface. We're looking at center points. All right, so then he calculated, all right, how far is the circle of the moon's orbit lies below the straight line. Remember that 90-degree diagram that we saw yesterday or on Wednesday? Sorry. His value turned out to be 1.4 millimeters below that tangential line. So he said uh, he was unsure exactly about the Earth to Moon distance, but he kind of figured that this is what it would be, and got kind of close to it. So this diagram that you see here on this page is very important to kind of tie it all in. Where you see the red moon, that's where the moon would be without gravity. Meaning, if there was just if the moon was flying away at some point in time, there was no gravity, the moon would fly away tangentially and be in that position. Well, the green one is where the moon actually is with gravity, and it falls 1.4 millimeters below where it would um, if there was no gravity. Again, you can see up top it says the distance the moon travels in 1 second. There you go. Okay, so he's making some pretty bold statements with very limited resources. So he wasn't really able to fully complete his thought because there wasn't enough math there to help support his answer. He could only do that once he created a new math that we now use as a pretty upper level course as calculus to prove his center of gravity hypothesis. It still holds true today. So why doesn't the moon hit Earth? Because we say that the moon falls around Earth because it falls that 1.4 millimeters below the tangent line. So then, can we apply the same concept to falling Earth? And I don't want you to lose sight of these big ideas that are said before each section, but it says here the Copernican theory of the solar system. You should know what that is. It should not fall on you and go, all right, I don't know what that is. It's Copernican theory. It is the theory that Copernicus came up with that the Earth is not the center of the universe, the sun is. So Newton's theory really kind of confirmed that Copernican idea. No longer was Earth considered the center of the universe. It became clear that the planets orbit around the sun, and the planets continually fall around the sun in some sort of closed path, which we later have called it an orbit. So you see here, the red line is that tangential line where it would be going if there was no gravity holding it in place. But there is gravity, there is a pull, there's a centripetal pulling it back towards the center, because we know that every planet interacts with the sun. There's that pull back towards the sun. So if the tangential velocities of the planet were reduced to zero, then their motion would be straight towards the sun, meaning if they have no uh, outward pull or outward velocity, then it's just going to go towards the sun because gravity is going to win. Any objects in the solar system with insufficient tangential velocities, they've not lasted. They've crashed into the sun, and they no longer exist. So, what theory of the solar system did Newton's theory of gravity confirm? It is the Copernicus or the Copernican theory of solar system. And you know what? That's it for this thing today. Hopefully you got something from it, and I'll talk to you later.